All right, let's get ready for a showdown. We're putting two absolute titans of the materials world head to head. Now, this isn't just about a couple of pieces of metal. Nope. This is a story about strength, about resilience, and really about that relentless human quest to build things better, stronger, and safer.
You ever stop and think about this? What really is the difference between the aluminum in a soda can and the aluminum in a fighter jet? I mean, they're both aluminum, right? Well, they are worlds apart. The metal in that jet is a high-tech alloy engineered to handle unbelievable stress. Because let's be real, when you're pulling G's thousands of feet in the air, failure is just not an option. And this is exactly where material science becomes so incredibly important.
So, in our tale of two alloys, it's time to meet the competitors. In this corner, we've got the incumbent, the reigning champ, AA7175-T7452. This is a trusted, widely used alloy that's been the go-to for a long time. And in this corner, we have the challenger, AA70850. This is a newer, 7th-generation alloy, and it was designed specifically to push the absolute limits of performance.
You know, like any great recipe, the real secret is in the ingredients. Just take a look at the zinc content. The Challenger, AA7085, has a way higher percentage. And that one little difference, that is a major clue as to why it performs so incredibly well, as we're about to find out.
Now, to make sure this was a fair fight, both of these alloys were tested in the exact same form, this large, forged hollow cylinder. And this isn't just some random shape. This mimics the kind of components used in really high-stress situations, so the results are going to tell us exactly how these metals would perform out there in the real world. So how do you find out which alloy is truly the best? Well, you put it through the ultimate stress test. Let's break down exactly how scientists pushed these metals to their breaking point. Here's something that's absolutely crucial to understand. A material isn't always equally strong in every direction. Think about it like the grain in a piece of wood. It's way easier to split it along the grain than against it. So, to get the full picture, the researchers tested samples from 3 different orientations: radial, circumferential, and longitudinal. The whole testing process, which is based on some really rigorous industry standards, basically boils down to 2 main challenges. First up is the tensile test. You pretty much just pull a sample until it snaps. This measures its raw strength and also how much it can stretch. Then you've got the fracture test. Here, you intentionally start a tiny, tiny crack and then measure how much energy it takes to make that crack spread. This one is critical for understanding how a material can resist a catastrophic failure. Okay, the alloys have been forged. The gauntlet has been run. All the data is in, and now it is time to declare a winner. First round, yield strength. This is basically how much force a material can take before it permanently bends out of shape. And wow, the result is a decisive blow. The Challenger AA70850 is a full 25% stronger on average. That is a huge advantage right out of the gate. But you know, strength isn't everything. A material also needs to have a little bit of give. We call this ductility. It's the ability to stretch before it actually breaks. And what do you know, AA70850 takes this round too. It can stretch significantly more, which means it's not just stronger, it's also more forgiving. It's much less likely to just snap when it's under pressure. And now, for the final round. Fracture toughness. This is the big one, folks. This is all about the ability to resist a crack that's already there from getting worse. And this, well, this is a knockout. AA7085-0 is, on average, a staggering 70% tougher. I mean, that is just incredible. It means it's vastly more resistant to the kind of catastrophic failure that every engineer has nightmares about. And you don't have to take my word for it. The source study itself concluded that AA70850 demonstrated superior mechanical properties. In other words, it didn't just win, it absolutely dominated across the board, in strength, in ductility, and in toughness. The challenger has officially and decisively unseated the incumbent. Okay, but why? Why was the victory so one-sided? What's happening down at the microscopic level that gives the challenger such a massive edge? We've got to take a closer look. These images from a scanning electron microscope, they tell the entire story. On the left, that's our winner, AA70850. Just look at all those little dimples and torn ridges. It absorbed a ton of energy. It stretched and pulled apart almost like taffy. Now, look at the incumbent on the right. See how it's a much cleaner, sharper break? That type of failure is called cleavage,
and it's much more like a piece of glass suddenly shattering.
And this gets us to the absolute core difference between these two metals. It's ductile fracture versus brittle fracture. A ductile material, it gives you a warning. It bends, it deforms, it absorbs a ton of energy before it fails. A brittle material, on the other hand, it just goes, suddenly, with almost no warning at all. And for any critical component, you always want that ductile failure. It's safer, it's more predictable, and it's just plain more resilient. So we have a clear winner, and we even understand the science behind why it won. But what does this actually mean for us, for the world outside the lab? Why does any of this matter?
Oh, it matters immensely. A superior alloy like AA7085-0 lets engineers design parts that are just as strong but using less material. That means lighter, more fuel-efficient aircraft. It means naval ships that are stronger and more resilient. And most importantly, it means critical components in all kinds of machines are safer and more durable. It lets us push the boundaries of what is even possible.
And that kind of leaves us with a final thought, doesn't it? We often think of innovation as a new design or a more powerful engine, but sometimes the biggest leap forward comes from the very stuff we build with. The next generation of technology, the next great leap in engineering, might just be standing on the shoulders of a new generation of materials.